Okay, we're going to work with some trigonometric half and double angles. Our first problem here, we have an inverse sine and an inverse cosine, and when we're working with inverse functions, we're putting in a value and we're getting out angles. So we can imagine these to be angle A and angle B. Now these are both positive, so our corresponding triangles are going to be in the first quadrant and they're going to look like this. And this is cosine of A minus B, which is the same as cosine of A cosine B plus sine A sine B. Now that we know that, we can just plug in our A and B values, and we should get an answer of 4 plus 3 radical 3 over 10. Now again, we've got an inverse cosine, and this time a negative 4 over 5. So the associated triangle would be this one in the second quadrant here. And knowing that sine of 2 theta is 2 sine theta cosine theta, we can plug in our values, and we should get negative 24 over 25. Now this time we've got an inverse tan function, and it's positive, so that's going to put our triangle in the first quadrant. Now, since we're using cosine of 2 theta, we've got a couple different options, but we're going to use the identity 2 cosine squared theta minus 1 for this example. And once again, now that you have all this, you can just plug everything in, and you should get negative 7 over 25. Now here we've got an half angle with an inverse sine. And since this is a positive value, our associated triangle is going to be here in the first quadrant. And our identity, because we're squaring it with the cosine squared, the positive, negative, the square root, and the square are all going to cancel. And really, we're just going to be looking at 1 plus cosine theta over 2. And lastly, you just plug in all your numbers, and we're looking at an answer of 9 over 10.